Welcome to Astronomy Daily, your trusted source for the latest space and astronomy news. I'm Anna.
And I'm Avery. We've got some fascinating stories today, from SpaceX testing new capabilities at the International Space Station to some surprising revelations about solar eclipse predictions.
Plus, we'll dive into a long-awaited discovery involving Jupiter's moons and get an update on SpaceX's ambitious Starship program in Florida. Let's jump right in. Before we dive into today's main stories, I have to say, this has been an incredible week for space news. It feels like we're living through a real renaissance in space exploration.
Absolutely, Anna. Between private companies pushing the boundaries and NASA's missions revealing new discoveries, it's hard to keep up sometimes. Speaking of which, our listeners have been asking for more technical detail in our discussions, so we'll be diving deeper into the science today.
Our first story takes us to the International Space Station, where SpaceX just completed a crucial test that could be game-changing for the station's future. On September 3rd, a Dragon cargo spacecraft successfully performed what's called a reboost of the ISS, using two of its Draco engines for just over 5 minutes.
That's pretty impressive, Anna. So what exactly does reboosting mean for those who might not be familiar?
Great question. Basically, the ISS is constantly losing altitude due to atmospheric drag, even though it's about 250 miles up. Without regular boosts, it would eventually fall back to Earth. This particular test raised the station from roughly 250 miles to an orbit between 256 and 261 miles.
And I'm guessing this is especially important because of the whole situation with Russia potentially leaving the ISS program by 2028.
Exactly. Right now, Russian Progress vehicles handle most of the reboosting duties. If Russia withdraws, NASA needs alternative capabilities, and this test proves that SpaceX can step up. They actually did their first reboost test back in November 2024, and now they're planning longer burns for fall 2025 to really put the system through its paces. It's worth understanding just how complex these reboost maneuvers are. The Dragon spacecraft has to fire its thrusters in precise coordination with the ISS's attitude control systems. Too much thrust, and you could destabilize the station's orientation. Too little, and the reboost is ineffective. The fact that they achieved a 5-mile altitude increase with just a 5-minute burn shows incredible precision.
It's also worth noting that SpaceX will eventually need these same capabilities when it comes time to safely deorbit the ISS in a controlled fashion. So this testing serves multiple purposes.
Now, shifting our focus from low Earth orbit to much deeper space, we have some fascinating news from NASA's James Webb Telescope. Researchers have identified what might be the most distant galaxy ever observed, designated Jades GS Z13.0, which appears to have formed just 325 million years after the Big Bang.
That's incredibly early in cosmic history. Just to put that in perspective for our listeners, if the universe is about 13.8 billion years old, this galaxy formed when the universe was less than 3% of its current age. How are astronomers able to determine such precise ages for these ancient objects?
It all comes down to redshift, the phenomenon where light from distant objects is stretched to longer, redder wavelengths as the universe expands. The Webb telescope can detect these incredibly redshifted signatures in infrared light. What's remarkable about this particular galaxy is that it's not just distant, but it's also surprisingly massive and mature for its age, suggesting that galaxy formation happened much faster in the early universe than we previously thought.
This discovery is really challenging our models of early cosmic evolution. The fact that we're finding these large, well-developed galaxies so early suggests that the first stars and galaxies formed even faster than our simulations predicted. It's discoveries like these that make the James Webb Space Telescope such a game changer for astronomy. Now, speaking of precision and accuracy, Our next story might surprise anyone who's ever looked at those crisp, clean solar eclipse maps. Turns out, those neat lines showing the path of totality, they're not nearly as precise as they appear.
Oh, this is fascinating stuff. What's the issue exactly?
Well, it turns out the edges of totality are actually fuzzy and can be off by hundreds of meters. The problem stems from something pretty fundamental. We're still debating the sun's actual size. The canonical radius that's been used for over a century is 696,000 kilometers, but new measurements suggest that might be outdated.
So, how much difference are we talking about here?
Researchers Luca Quaglia suggest the sun's angular size is 959.95 arcseconds versus a traditional 959.63. That's a tiny difference, but it can shift the eclipse path edge by up to 2,000 feet. When you factor in the sun's fuzzy photosphere and the moon's jagged mountain peaks, things get even more complicated.
So, what are researchers doing about this?
They're creating new maps with zones of uncertainty at the edges instead of those precise lines we're used to seeing. This is especially important for the August 12, 2026 eclipse that will affect Spain and Iceland. People planning trips definitely want to know about these potential variations.
This research is also revealing some fascinating details about the lunar limb profile, the jagged edge of the moon created by mountains and valleys. These irregularities can create what astronomers call the diamond ring effect and Bailey's beads during eclipses. Some areas along the eclipse path might experience these phenomena more prominently than others, depending on which lunar mountains are silhouetted against the sun.
Before we head out to Jupiter, let's take a detour to Mars, where NASA's Perseverance rover has made a potentially groundbreaking discovery. The rover has detected what scientists are calling convincing evidence of ancient microbial life preserved in a rock sample from Jezero crater.
This is huge news if confirmed. What exactly did Perseverance find that's got scientists so excited? I know they've been looking for signs of ancient life in Jezero craters since the rover landed.
The evidence comes from a rock nicknamed Chayava Falls. Perseverance found distinctive chemical signatures and microscopic structures that are consistent with ancient bacterial mats. The rock contains organic compounds, mineral deposits that typically form in the presence of water, and what appear to be fossilized biofilms. Of course, scientists are being very cautious. They need the samples to return to Earth for definitive analysis, which won't happen until the Mars sample return mission in the 2030s.
What makes this discovery particularly compelling is the location. Jezero crater was chosen precisely because it contains the remains of an ancient river delta, an environment that would have been perfect for microbial life billions of years ago. If these findings are confirmed, it would be the first concrete evidence that life once existed beyond Earth, fundamentally changing our understanding of biology in the universe. Okay, our third story takes us to Jupiter, where NASA's Juno mission has finally solved a long-standing mystery. After years of searching, they've detected auroral footprints from Callisto, the fourth and most distant of Jupiter's Galilean moons.
Wait, so the other three moons, Io, Europa, and Ganymede, they already had detected footprints?
That's right. These are basically auroral signatures that show up in Jupiter's atmosphere as each moon passes through the planet's magnetic field. Think of them like cosmic breadcrumbs. The other three moons had been spotted before, but Callisto's remained elusive despite multiple attempts with the Hubble telescope.
So what changed? How did they finally spot it?
The breakthrough came in September 2019 when a massive solar stream hit Jupiter. This shifted Jupiter's main auroral oval, and in that shifted configuration, Callisto's faint signature finally became visible. It's much weaker than the others, which explains why it took so long to detect. But now we can confirm that all four Galilean moons leave their mark on Jupiter's magnificent auroral displays.
This discovery also tells us something important about Callisto itself. Unlike the other Galilean moons, Callisto was thought to have a relatively simple, undifferentiated interior. But the fact that it creates detectable auroral footprints suggests it has some kind of conducting layer, possibly a subsurface ocean like Europa and Ganymede, which would make it another potential target in the search for life.
And finally, let's talk about what's happening much closer to home, here in Florida. SpaceX is making rapid progress on their Starship infrastructure at Kennedy Space Center, and the scale of what they're building is pretty remarkable.
This is at both Launch Complex 39A and Space Launch Complex 37, right? What exactly are they building?
At 39A, they've assembled a large crane and are erecting a service structure, with the launch mount potentially in place by the end of this year. But Space Launch Complex 37 could be even more impressive. It might support dual launch towers and could handle up to 76 annual launches.
That's an incredible launch cadence. When are they targeting their first Florida Starship flight?
SpaceX is aiming for late 2025 from Launch Complex 39A, though many observers think 2026 is more realistic. Environmental reviews are currently evaluating up to 44 annual Starship launches from Florida, which would represent a massive increase in the state's launch capacity.
The scale of this infrastructure development is really staggering. We're talking about launch towers that will dwarf even the vehicle assembly building at Kennedy Space Center. Each Starship Super Heavy booster stands nearly 230 feet tall, and the complete stack with Starship reaches about 400 feet, taller than the Statue of Liberty. The ground systems needed to support this massive vehicle require entirely new approaches to fueling, servicing, and launch operations.
From an economic perspective, this could transform Florida's Space Coast. With up to 76 annual launches from just one complex, we could see launch frequency that rivals the entire global launch industry today. That means thousands of jobs, not just for SpaceX, but for the entire ecosystem of suppliers, contractors, and service providers that support these operations. It's reminiscent of the Apollo era, but potentially even bigger.
It's amazing to think that 39A, which launched Apollo missions to the moon and space shuttle flights for decades, will soon be home to the next generation of spacecraft designed to take humans back to the moon and eventually to Mars.
Absolutely. And that wraps up today's episode of Astronomy Daily. From SpaceX testing new ISS capabilities to discovering the limitations of Eclipse maps. From completing Jupiter's Aurora Moon collection to building the launch infrastructure of the future. It's been quite a journey through the cosmos.
Looking at all these stories together, there's a common thread. We're witnessing unprecedented precision and capability in space exploration. From SpaceX fine-tuning orbital mechanics at the ISS to JWST revealing the distant past of our universe. From potentially finding ancient life on Mars to mapping Jupiter's complex magnetosphere. Each discovery builds on the others.
What's particularly exciting is how these developments are accelerating. 10 years ago, many of today's stories would have seemed like science fiction. Routine commercial operations at the ISS, telescopes seen back to the cosmic dawn, potential biosignatures on Mars. The next decade promises to be even more remarkable, with lunar bases, Mars sample returns, and interstellar missions moving from concept to reality.
Thanks for joining us today. Don't forget to subscribe and share Astronomy Daily with fellow space enthusiasts. We'll be back tomorrow with more exciting discoveries from the universe around us.
Until then, keep looking up. I'm Avery.
And I'm Anna. Clear skies, everyone.